ANSYS version 18, Fluent Analysis. In version 18 of ANSYS, the Fluent interface is changed. So this lecture is about introducing the new interface in Fluent. So first of all, we draw the geometry in SolidWorks and enter ANSYS workbench like this. And then we drag Fluent and drop on geometry and enter mesh procedure. And this is the mesh procedure. There are two things we need to do here. First is to define the inlet and outlet surface. So this is the inlet surface by name selection, outlet surface. So we have created two name selections, the inlet and outlet surfaces, and then we mesh the geometry. So this is the end of this procedure. Now we enter. You can save the procedure first, give it a name and save it on desktop and enter Fluent. And this is for defining the hardware, whether they are parallel processors or there are double precision options. So we take the default for the hardware and we enter Fluent interface. So this is the Fluent interface, and this is the step 1, general. So we can see that there are options here. We can see these options here. So this is the menu tree, and these are the toolbars and drop-down menus. And the second step will be the models, material, and cell zone conditions. So these are the step 2, initial conditions. And these are the step 3, boundary conditions. And step 4, goals or monitors. Step 5, running the calculation. And step 6, result. And all the tabs here are toolbars above here. For example, models here, materials is here, zone conditions here, initial condition are all here for the setting up. Setting up means it is preprocessors. So we have boundary conditions hiding here. Actually, I don't think it should be here. It should be a separate tab, but it is hide here. So this is the step 3, boundary conditions and dynamic mesh references. And then for the solution method, we can change to solving. These are the solution method and controls, reports, and monitors, and also initial values, initialize, and calculation activities, and run calculations. So these are all toolbars corresponding to the menu trees. And we have also post-processors. So now we have come to the second step, which is the definition of models. But for the second step, we are not going to choose anything here because there's no heat, no radiation, no exchange, no species, no discrete phase, no solidification, or no boundary movement. So we take it as default. And then for materials, there are materials for fluid and solid, and we have to change. We have to add a new material because we are going to run a flow analysis for water. So we hit this Fluent database tab and choose water liquid and copy it and close. So we have 2 fluid to choose from. So this step is to load the material, and the next step, cell zone condition, is to connect the geometry with the fluid, the material. So there are 2 parts of defining material. This step is to define loading a material, and this step is to connect the material with the geometry. So we have finished with the material part. And so we have finished with the second step, which is the initial conditions. And the next will be the step 3, boundary conditions. And for inlet, we choose mass flow rate. And the mass flow rate of 0.5 kilogram per second, and normal to the boundary. And for the outlet, the default is pressure outlet, and it is 1 atmosphere pressure, so we accept the default. And also for the wall, we also accept the default. So we have finished with the step 3, and we accept defaults for all these steps. And you can, of course, you can define your own report definition. I'm not going to do it. Step 4 will be the monitors, and this is the convergence criteria, and the default value are 0.001. It is the default value of the software, so we accept the default for step 4. And step 5 will be the initialization. We can choose it here or choose it here. And we use hybrid initialization as a default and click on initialize. Or you can click on here, the initialize. They are equivalent. So I click here. So we generate the initial value and then calculate activities. You can define whether you are going to save the iterations. I'm not going to save the iterations. So now we'll run the calculations. You define how many iterations to calculate and then perform the calculation. So this is the step 5 calculation. And you can see that the convergence are reached actually at 50 iterations. If you are not comfortable with the result, you can calculate another 50 iterations. So now I have reached a stable value of the outcome. So I'll get to the post-processors, the result, and we can add in a pressure contour plot on the inlet, outlet, and wall. We will display with a field surface. So this is the pressure drop. And then we'll show a vector plot for the velocities, inlet, outlet, and interior. We will display the vector plot. And then we can display path lines or the flow lines from inlet to outlet, and we'll make it velocity using arrows and lines, and we'll make the arrows smaller, and we can display the velocity flow lines, and we can make it continuous animation. We can also make a single animation, continuous animation for the flow lines. So this is the tutorial for Fluent version 18 new interface.